Okay.
We are 12, so that's I think enough people to start. So let's start.
All right. Can everyone hear me?
Yes.
Okay. All right. So yeah, hi everyone. Today, as mentioned, we would be talking about the system design for metrics monitoring system. In case I have pinged the link in the Discord group, I will also ping it over here in the chat in case people want to read about it. So this is the article that I wrote, and I would just be going over my thoughts on how we should tackle this system design question during an interview. So the question typically goes along the lines of they just come in and say, okay, design a metrics monitoring system without giving us any additional data. So it's our job to clarify the use case and other specific requirements. So this is my view about how the requirements would look like. So in this case, what we are discussing or talking about is a system which I think if you have worked in an industry, you must you must be familiar with monitoring systems where you just see graphs for the memory usage, the CPU usage of various services that you run. So that is the typical system I am also keeping in mind while answering this question. So in this case, I would just be looking at some medium-sized company that has a fleet of machines, and those fleet of machines would run a set of services. Those services could be anything. And another key requirement here is that it's not just standard predefined metrics, but we can make the service owners or the application writers export custom metrics. Like it could be anything. They could just compute any random variable. It could be any type, and they can just export it. And we should be able to, collect metrics and store them and visualize the data for them for quite some time. One few more questions that I would like to ask if I were the person attending the interview would be how long should the metrics be persisted? Typically, it should be persisted for a decent amount of time because we want to be able to debug long-standing issues. Another question I would ask is this primarily for use internally inside the company, specifically inside the company network, or are we also trying to expand our service to monitor machines outside of our company network, which will come in handy later on during this talk. Another thing I would like to get clarified is, are we only monitoring continuously running jobs, or is our use case primarily geared towards batch jobs? So the difference here is that primarily continuously running jobs have the flexibility to keep on just pinging the servers that we have with the metrics that they compute periodically. So but then we don't have that flexibility with batch jobs because batch jobs just run for some time and then just disappear. So we should be able to make sure that the jobs which are running have the ability to push the metrics to our system before they finish their execution. So in this case, I am assuming that we are primarily interested in continuously running jobs, and batch jobs are kind of out of scope for this discussion at least. We should also get clarification about whether alerting is what the interview is looking for, because that itself is kind of a complicated topic. In this particular talk, I am not going to go deep into the alerting details. I have some ideas, high level ideas, but then it's not clear to me exactly how it would work. I hope there is.
Yeah, I'm just
yeah, I'm
sending.
not looking at the chat. I guess I will not be looking at the chat continuously.
Yeah, of
But
course.
if
Yeah.
anyone has any questions, let me know.
Yeah. Well, I'll interrupt you if I have questions.
Sure. Okay. Going to the scale and estimations. This is quite standard. So all we need to do is look at. So this setup is very simple. There are some n number of services, m number of machines, and I don't know, p number of metrics. So we just multiply all of them together to get the total number of data points that can potentially be exported at a certain regular intervals of time. So in this talk, what I am assuming is that there are going to be 10,000 machines in the entire fleet for the whole company, and there are at an average, on an average, 1,000 metrics that are being exported per machine. And I would also be assuming during this talk that we would collect metrics at the granularity of per second granularity. So imagine we are just pinging the machines and collecting, hey, how much CPU are you running at? And then come back next second, then ping the same machine and say, okay, how much CPU are you running? Do that for every single machine across the entire fleet. So that gives us a number of data points to be 10 million. And since we are doing it at per second granularity, we are expecting something like 10 million data points per second. And as noted earlier, we are persisting it for long term. At this point, I'm just mentioning that as 2 years. So what this means is that we need to be able to ingest all of these data points at the rate of 10 million data points per second. And we should not lose it for a long time, which means it should be eventually funneled into some kind of a persistent store, which means we should somehow design the key problem, at least according to me, the heart of the problem is how do you ingest so many data points at the rate of 10 million per second into a persistent store and scale it out in such a way that people can also query it.
Yeah, and to be precise, yes, the query, we've talked about it before, that this is tricky, right? Because did you decide on your design to allow for ad hoc queries? And what I mean by ad hoc queries is you can pretty much ask anything you want, and it should be retrieved in a decent amount of time.
Correct. No. So the query will only be typical queries that developers do for monitoring, and that is usually on a timestamp or time range queries. For example, the only type of queries that we would allow are, I have this service A or my service, and I am interested in this metric, for example, CPU, and I want to know the CPU usage for these parameters for a specific time range, typically ranging a few hours. That is the only type of queries that we would support.
Okay, so for example, if you want to filter the queries by their by a tag that they have, let's say we decide to tag queries by a certain.
Correct.
We don't care about that, and we don't support this.
We do support this actually. We are going. I am talking about metric, what a metric is, and how a metric is defined in this following section. And there I am introducing tags.
So if you don't support ad hoc queries, what type of queries don't you support?
So for example, what are all the metrics for my service A? Those kind of metrics are not supported. For example, what are all the services are there, or how many machines are being run for this service, stuff like that. Unless you explicitly export it and query it over time, you won't be able to query it.
How many machines are? This is a different query.
Correct.
I guess my question will be more clear when we tackle the store, the data store that you're going to use to query.
Sure. Okay. Yeah. But then, yeah, so for the majority of this talk, you can just assume that the query is going to be a typical query you see in all the monitoring graphs, which is, I want to know the CPU usage of my service over the last few hours. That is the most basic version that I kept in mind while writing out this particular article. I do introduce some concepts like tags and stuff that does come into play, but then I don't go too deep into this. I just gloss over some details. Okay. So I think in case it is still not clear, I will spell out exactly what I mean by a metric. A metric is, number one, always associated with some value and some timestamp. So in this case, the metric is num users, and it's always associated with, is now at this moment associated with this number and always and this always coming in at some timestamp. Now, the metric itself is typically in this format. So usually the first part of the metric is the machine ID or the machine number that is exporting that service. For example, any service, in order to support replication, people have multiple instances of the same service running in multiple machines. Usually they are numbered 0 to some n or n minus 1. So that would typically be the first part of the metric. The second would be the identifier of the service itself. So it could be service A, service B, whatever. The metric name would be the actual thing that you are interested in. For example, CPU, memory usage, or in this case, num requests, which could be application specific. You can write a counter inside your code, which increments every time you receive a request, and we will provide libraries to export it in such a way that it will show up in the monitoring dashboard. And the tags are the ones that we were that are kind of interesting. So usually in all these monitoring dashboards, it allows you to also specify some set of tags along with the queries. For example, the example that I am talking about here is that in your application code, you could say that you are interested or classifying the users based on their country and also based on whether they are premium users or not. That could be totally application specific. You could add arbitrary number of tags along with the metric that you are exporting. In that case, we should also support querying in any of these tags. For example, if you are specifically interested in the number of premium users who queried from USA, your query would look like this. If you are only interested in all the number of all the users total, you just drop this entire tags section and just say 0 or my service.num requests. If you're interested in only num requests from US across all the classes, you just drop this and only query for this.
Okay, so this is the number of requests during a second here in that case.
So this is the number of requests. This is one single data point. So this is the number of requests.
In what time? In what timestamp?
This timestamp, this one.
This one, and so here I have a problem. The number of requests, it necessarily has to last a certain amount of time, right? Where is this information? Like, how do we know if we got this number of requests is like 1 milliseconds or 1 second or 10 milliseconds?
Yeah, so that would be application code, right? So you can export whatever you want as in the form of integers or maps or histograms or whatnot in your application code. So whatever you computed, whatever that application considers as num requests is what is exported. Does that make sense?
And so what would you choose, for example, for this type of metric? How would you represent it? Because something is missing here right now. Like so, you said it depends on the code implementation, but where would be this data and how would it be represented?
So at least in my mind, yeah, at least in my mind, we can provide, maps to be exported for this. So if you are just computing the number of requests total, it could be as simple as an integer. All you can do is increment a counter whenever you get a request and then export it as an integer. If you are interested in exporting, let's say something like this, what you can do is export. We should provide a way to export maps, or we should maybe provide a way to export, let's see. Yeah, I think maps would be what I would be exporting, and you can have arbitrary number of keys inside your map. So in this case, whenever a request comes in, your application code should probably increment the num requests based on the query properties.
I don't understand how this solves the issue that we don't know the number of requests if it was for the last 10 milliseconds or for the last second. But let's move on. I guess it's going to become more clear when we make this query.
Okay, yeah, sure.
So just to be we're going to stop at 9 p.m.
Sure.
PST, which is in 1 hour and 14 minutes.
Sure.
And then we have a feedback at in 1 hour and 40 minutes. That's going to last 15 to 20 minutes.
Sure. Yeah. Okay. Yeah. So the next, I hope at least some of the basics are clear to the people who are listening. The next big topic of discussion in my mind would be how we are getting. So we have two sets of two actors here technically. The first actor is the list of machines which are running some type of service inside your company. The second set of machines is the actual metrics monitoring system, which is trying to pull in or get the data from all these machines into some kind of a persistent store. So here we have two options here. The basic question is, how do we ingest all this data that is coming from all of these machines, from those machines which are external services, into some kind of a persistent store which are maintained by our systems? The two obvious approaches I can think of are push and pull. For the push approach, the idea is simple. We let the machines which are running those services call some of our APIs, find some servers that we run, and ping those servers saying, okay, hey, this is the metrics I have, take it. And they can ping at whatever frequency, or we could have some kind of mechanics in a way that we don't have to do anything, but we will be contacted by other machines which are running the services, reporting the metrics to us. As always, there are always going to be some pros and cons. So this works really well for batch jobs, because the batch jobs know exactly when it is going to finish, wrap up and die. So just before wrapping up, it could just collect all the metrics after running the batch job, collect all of these counters or whatnot, results and stuff like that, push it to our servers, and then just exit the system. For continuous running servers, it obviously works, because the servers which are running continuously can just keep on regularly pinging our service at whatever granularity time range that they want, saying that, okay, this is the set of metrics we have, take it. That's it. Another good thing about the push approach is that, let's say you are running a service which wants to get metrics from not just within your company's network, but in a different network as well. Or this could, let's say you are also interested in getting metrics from systems which are running in machines that are behind a firewall. In that case, the only way we can get the metrics out of the system is not by us contacting the machines ourselves, but by letting the machines ping the data to us. That would be better for us, because we don't have to do all the work of bypassing or whitelisting our machines to get it past their firewall and stuff like that. So yeah, so that was so the way I have explained it here is that the puller, which is, if we went with the pull approach, we would not be able to easily contact the machine that is actually getting the metrics. The downsides of the push approach is that we don't control the ingestion rate. We let the machines which are running the service ping us at whatever rate they want with whatever data they have, which means we are totally at their mercy for when it comes to ingestion rate. Another thing is, integration of the clients might be slightly difficult in my mind, because we have to let them call our API, find our servers, and then send it to us. So I don't know exactly how the integration story would look. Maybe it's easy, but at least in my mind, it seemed like we are putting the burden of finding our servers, maintaining connections with our servers, and then pushing the metrics on the shoulders of the application writers, which might be a little bit of extra work that might cause some friction when it comes to expanding our client base. Moving on to the next approach, which is the pull. Pull is very easy. All we let the application writers do is, okay, you know what? All you have to do is come. Yes, go ahead.
Why in the push model we can't control the rate?
The ingestion rate.
Yeah.
Because
why
they can.
Can't we?
So at least in my mind, the push approach that I had in mind was, we provide a set of APIs which will let the application writer or the machines ping the data to us in some format. So if we have that kind of model, then they could aggressively send huge amounts of data to us, which we have to either decide whether to throttle or we have to decide whether to process or not. So I think putting the control of ingesting the data on the client side might be causing some kind of imbalance.
Okay, I don't want to go into too much details, but someone
Okay.
mentioned that we could have used a flow control like TCP.
Okay.
If we have more time, we can talk about it
Sure.
in the feedback section. I don't think this is essential.
Okay. Okay. Yeah. So I think, at least in my mind, so let me try to explain the pull approach here, because all that we let the application writers do is, all you have to do is just export whatever metrics you want, compute whatever metrics you want, and expose the metrics as part of an HTTP endpoint. We have give that HTTP endpoint a specific name, something like always export all your metrics in the metrics endpoint. So, and that makes it very easy, because now the application writer doesn't have to care about our system or finding our system, none of that stuff. They also don't have to care about pushing, calling any APIs, none of that stuff. All they have to do is just compute the metrics and export it as part of the HTTP endpoint. And we will take care of scraping the metrics at whatever rate we can possibly scrape the metrics from these machines. All we have to do is contact, okay, machine x/metrics will give us a snapshot of all the metrics that are in memory inside the machine at that particular timestamp. Scrape all of those. Go again, ping after some time. Scrape, ping, scrape, and then keep pinging and scraping and ingesting at the rate that we want. So that is how the pull approach would work. I think this is easier for the clients to integrate with, because the clients don't have to do anything fancy. They don't have to call any of the APIs. All they have to do is compute the metrics, export it as part of an HTTP endpoint. We take care of the rest. Another thing is, we get control over the rate at which we are ingesting the metrics, because we control the scraping of the metrics. So if we find that there is too much data coming in, we can always optimize or calibrate the rate at which we are ingesting. This is like exact mirror image of the push approach.
But here I don't get it. In the pull, you say the monitoring system does the collection and storage. In the push,
correct.
You can also make sure that the monitoring system also does the collection. In the push model, the system sends data and the monitoring system takes care of the collection as
Correct.
well, right? So why
Correct.
are you saying that pull collect?
So I think by collect I meant scrape, I think. So someone needs to, so there is the system that is running some service, and there is the monitoring system. So there needs to be some kind of a connection between these two systems. That is essentially my point, right? Now, does the connection come via the services contacting us, or should we contact the service to get the metrics? I think that is the point I'm trying to answer. Does it make sense?
I see.
So
okay.
who makes the connection? I think, or who initiates the connection and gets the data? So should we be proactive and get the connection, pull the data from them, or should we let them be proactive or whatever to contact us saying, okay, this is the data I have? So that is the question I'm trying to answer here.
I see.
So one question on the pull approach. Does it interfere with the regular flow of our API services? Let's say you're already dealing with a lot of burst of events or request API requests, and your monitoring system is coming and looking for the metrics, right? How do we handle that, or how do we control that flow?
Correct. Actually, that is a good point. I wanted to cover that as part of a con, but what you have mentioned is that it is one additional request that the API servers need to handle. And if the API servers are already overwhelmed, they would not be able to serve this request. Is that right?
That's right.
Yeah, I think that is a con of this approach, in the sense that so then we should probably, at least in my mind, first of all, set some reasonable rate at which we query. I was thinking once a second is not too bad. But then if we get complaints from the clients or the services saying, okay, we are already overwhelmed most of the time, please don't query us so often, then we can have some configs where we say, okay, we have to only ping this particular service only once every 15 seconds or so. So that is what I can think of. If they can't even do that, then I think, I don't know, I think that that is probably not realistic in any scenario, I think. Does that seem okay?
Yeah. I know you're getting into the decision part of it, right? I basically, please make me understand, like, why you have gone for the pull approach versus the push.
So yeah, so at least for me, in the pull approach, I think that my major reason for this is because we don't really, at least based on the constraints that I have set up in this imaginary interview, I don't deal with batch jobs, and I don't deal with machines that are outside the company network. And at least in my mind, I would like to be in full control of the ingestion rate, which is which I'm getting with the pull approach. And I would want my service to be adopted quickly by putting less burden on the clients, which is, in my mind at least, easier with the pull approach. So given that it is checking all the boxes, yes.
With the controlling the ingestion rate, I mean, with the push approach, can you have like a rate limiting on the monitoring service? If you wanna control the flow of the ingestion rate, like I guess we can implement some sort of like a rate limiting in the monitoring service. Okay.
Yes, so the rate limiter should be, at least in my mind, right? I think there is still some kind of, so that would be, sure, you would be putting more work in order to rate limit. So at least in my mind, you have, that is more work on our side. Even though it seems like clients are pushing the data to us, it's still like we have to do all these checks and other stuff to make sure things are happening. So it seems like there is burden on both sides, the clients, for them to call our service every time they have some data, and for us to verify, make sure that we are not overwhelmed. So instead of that, having just us pulling whenever we want seemed like a place where we have better control over the entire thing. At least that was what I had in mind.
Okay, thanks.
But then that is how I would try to talk about it. But then it's a tricky topic, to be very honest. I don't think there is a very nice proper answer here. But then if the interviewer comes and says, okay, you have networks, you have to deal with external networks, that puts a firewall in front of the machines that we want to access, in which case push is the best approach. So if there is no clear differentiator, I think it could go either way. And I just leaned towards easier client integration, and also have more control over the ingestion rate, because I want my systems not to be overwhelmed. I think that was my only
so
thing.
one approach, one con,
Sure.
I'm thinking here is,
Sure.
so you're being in the metric side of the application, and let us know if you're going too deep into this. Feel free to stop. So being inside the metrics and that perspective, you're kind of designing that system, and you're going to ask the service, hey, give me your metrics at any point of time, like 9 a.m., 10 a.m., 11 a.m., like that, right? So how you're going to maintain that, what server you're hitting or what particular containers you're hitting, and how are you going to maintain that with a pull approach, right?
Correct. So
now being in the
go
metric system, I have to be aware of what are the services that my infrastructure has, how many services are there, right?
Correct.
That is some little bit of tight coupling with the client applications.
So I don't know about tight coupling, right? But then that is just a lot more work that we have to do in order to so you are essentially talking about service discovery on the client side. So if let's say if we want to maintain metrics for service X, we have to make sure that we know that service X exists. We need to know what machines are part of service X, and then we need to know how to discover them and scrape their metrics. So that would be let's see, I don't have this as part of the so I think that is what I meant in this con. We need to do service discovery, maintain the mapping between our set of scrapers or collectors and the list of target machines to be scraped. Is this what you mean?
Yeah.
Okay. Yeah. So that is a big complexity on the metrics monitoring design. I still think I think this is, at this point, personal opinion, I think it's okay because it puts less burden on the clients. And the only thing the client needs to do, at least in this system setup, would be to maybe update a global config for the list of all the services that will be monitored by your system. So if you are bringing up a new service, all you do is go to some kind of a file or a global file or something, update saying that, okay, my service, add it to my list, so that gets monitored.
Basically,
I think that would be the only thing.
Service itself kind of gets onboarded itself. Correct. Onto the
Correct.
Okay.
So on the flip side, right, on the push side, you don't need to do this, but you can just bombard the server. But then I think you would have to decide. I'm sure we can write API or client libraries for it. We will provide you some. We have tried some client libraries so that you can discover our metrics monitoring system as a client, choose which one to push to, and then push it, or something like that. We can put a load balancer in front of all this and then route the requests. That is also a perfectly reasonable approach. I just happen to go with the pull approach.
One question.
Yes.
In the pull approach, right, how much time it will take to pull the metrics from all the clients?
I don't know. I'm thinking it should be quick if we can use threads to pull in all the metrics, I would think. So it would be just a HTTP GET, and the HTTP GET would give you current snapshot of all the metrics that have been computed inside the machine. That's it. So it should be quick, I would think.
If it takes more time, right, won't some clients will be dangled for the next time? Let's say if it takes hours to pull the data.
It will not take hours, I think. We are talking about at an average maybe thousands of metrics per machine. And imagine something like you go to a web page, you just get the list of metrics in some form, or if you ping the my service / metrics page or URL, you just get a JSON. That's it. So it will be as quick as that. So maybe a few KB, which is not too bad. So it will not take hours, in my opinion.
So a follow-up question on that.
Yeah.
What will happen when the machine whose metrics we are pulling is busy and not responding, right? So in that case, the pull API will be waiting for a long time, and it could cause potential performance problems like thread waiting issues and all those stuff, right?
So on what side will it cause, just for my understanding? On the puller side or in the machine's service side?
On the puller side, like we are trying to pull data, right? So we are requesting the API, but we are waiting for the metrics to be delivered to us, and the machine whose data we are trying to pull is busy. It's not responding to our API.
Correct. I would think we can just put some kind of timeout and deal with this, I would think. Don't you think? So also we can use multiple threads to send HTTP requests in parallel to multiple machines. So hopefully one machine not responding should not affect all the other threads getting the data from us. Don't you think?
Yeah, just comparing that to the push scenario. In case if the machine is busy whose data we are trying to pull and it's not sending the data to us, then we don't have to bother about these scenarios, right?
Correct.
So don't you think in this scenario push could be a better approach?
Correct. Yes, that is also a good point. So that is actually a pro for push approach. Another thing is, yes, so we can, so if the machine is down, we can make the push approach send them retrospectively whenever they come up and whenever they feel comfortable sending the data. So that would be interesting. Yeah. So at least in my mind, it boils down to how difficult it is for a client, for let's say a service owner, to integrate their system with ours. If you think it is easy for them to take care of all the burden of calling our APIs, finding our service correctly, sending over the data over the wire, and then it seems okay to me. I somehow felt I was not comfortable with someone else controlling our ingestion rate. I think that is what it comes down to finally.
So this is where, for me, this is what the deal breaker is. It's that Since you are ingesting no matter what every second, what's going to happen is you're going to query your 10,000 machines every second. And so whether you query them with the pool model or you receive from them, the load is the same, right?
So wait, so the load is variable when someone pushes at you, because they could potentially push multiple times per second also, right? In our pull case, we'll just be pulling at whatever rate we want. In my example, I gave 1 pull per second.
And here's the way I see it. You're in a company, you are the monitoring team. People don't get to decide what they're going to run in their machines, right? The other services, the messaging service, notification service, they don't get to decide. They will install your client and they have no business doing anything else, you see? So you're a bit dictatorial, but that's, you know, that's the goal of the team, right? It's to enforce upon everyone else how monitoring should be done. There might be differences depending on the services, you could say, or maybe the notification service has different needs, etc. But you make it uniform, and so you make it so that the ingestion rate is 1 per second per machine per service.
Correct.
That's how I would sell it. But again, I see in the link that I just passed on the chat that the pool system is legit, right? Right now, we can see, I mean, everyone in the call, there seems to be a lot of people that are more towards the push. But that's great, actually. That's the goal of those calls, is to get to learn about different design. I was surprised by this design when I saw it the first time. And so continue and keep selling us your design, right?
Correct. So yeah, so looks like I have not sold it properly. I'm just now looking at the push. Sorry, I got distracted by the chat comments.
Yeah, no problem. It's normal.
But then, yeah, so I think, so as I said, right, 2 things in my mind: the ingestion rate. I think I'm repeating myself here, but ingestion rate, if someone pings me randomly at a large amount of rate, I have to, make sure that they are doing something proper. So that is one thing I had in mind. Another thing I had in mind was client integration, which is easier for some external client to integrate with us. Is it easier for them to just export their data to HTTP and put their service name in the global config and then forget about it? Or is it easier for them to, because the client that is installed defines the ingestion rate? Let's see.
You see, but the idea is that every service installs the, let's call it, I don't know, monitoring Facebook, for example. That's the name of the small service that they install along every other thing that they install in their machine. So every time you deploy, you have to install also this plugin or this service or this daemon. And this daemon doesn't send more than once a second or once every 500 milliseconds.
So just so I understand it, you are talking about a thing where the machine, the agent or daemon is also installed in the same machine as the service is running.
Oh, yeah.
And the service will then dump all its metrics, let's say at some rate, whatever, in its local disk, and the agent will keep on extracting this and then sending it over the wire to our.
And not even in the local disk, it's going to dump it into a domain name. A domain name, it can be whatever, it's the name of the service. So it's going to push it, send it to some sort of URL, or for that matter, an internal service.
Correct.
Load balancer.
So that push,
load balancer will
correct. And that point, then, yeah, so we have to put a load balancer and make sure that we are, yes. So I think, yeah, so there are 2 approaches here: put everything in the disk and then batch export at some rate, or we can make the servers ping our services directly, and we put some kind of a load balancer in order to make sure that we are not overloaded. Is that right?
Well, I see. I didn't think about pushing in the disk before sending it. I was more thinking about, directly sending to this load balancer in the push paradigm. But that's fine. Let's move on with the pool, right? Let's say we went for the pool, right? Because that's what you just built. And let's see if we were going for the pool, what this would look like.
Correct. So going forward, right, except for certain parts of the design, whether we do push or pull doesn't really matter, at least the way I have written the article. So we can quickly go over, let's see, is it clear now, the image? So people are able to see the screen, right?
Yes, and if you want, you can make it bigger because we see the Discord chat. I don't think it's intentional.
The Discord chat?
Yeah, it doesn't matter.
Maximize the Chrome.
Yeah, maximize Chrome.
Okay. I think that is fine. I think what I was asking was, are you able to see the actual thing? Okay, yes. Okay. Let's see. So yeah, so I think by now people who have followed this must be familiar about certain things in this picture. So the service A, service B are multiple instances of the same service. We have a set of scrapers. So we can't, I am assuming that just one machine cannot scrape the entire fleet of machines and get all the metrics at the rate of once per second. So we have to shard the work across multiple scrapers. So imagine lots of scrapers over here. And the scraper's job is very simple. Just let us for now assume that each scraper already knows what is the list of target machines it needs to pull the metrics from. Now that it has this data, all it does is just simply does a GET request for all these machines at a specific rate, compiles or gets all the results back, and then dumps them into the persistent store. Now, a small detail, or maybe a big detail, I would think, is how do we manage the list of service machines and list of scraping machines, and the mapping between what scraper is responsible for getting the metrics from which service instance. The way I would model it is using Zookeeper as the source of truth for the mapping between the scraper and which machine or the list of machines it should scrape. That is computed using some random sharding. So if you have a list of service instances that you already know, hash it and distribute it across multiple scrapers. And while you do that, persist it inside Zookeeper. And the scrapers are relatively dumb in that all they do is they get instructions from the controller. Yes, I will get to Akhil's question in a bit. We are talking, I think he's asking about the persistent store.
Yes.
But we will come to that. We will do actually a deep dive on the persistent store. So the scrapers are relatively dumb. What they do is just wait for instructions from the controller and then decide what machines they need to scrape. Once they know what machines they need to scrape, just keep on doing that stuff. What the controller does is make sure that it detects new services being added, new scrapers being added, new services being deleted, new scrapers being deleted, and redistribute the work, essentially just changing the mapping between scraper and the service inside Zookeeper. It understands whether a machine is going out or coming in because it subscribes to Zookeeper updates. So that is how I would describe this whole worker management scenario going on here.
Let's move on to the persistent store. I'm sure we have plenty of questions just regarding what you've talked about, but for the sake of time, let's move on to the persistent store.
Correct. I think it is simple, right? So other parts, so I have put some basic backbone for the alerts and stuff. We will probably not get to that. I think, yeah, so external services are the machines that we want to scrape. Scraper is the one that gets all the metrics. The controller is the one that gives us mapping between what scraper should scrape. Persistent store at this moment, just consider this as some kind of a black box, which just gets all the metrics. Okay. Let's see, how does scraper control contact scrapers? I would think all of that. So the Zookeeper should have the list of all the service machines and all the scraper instances. And at load time, the scraper controller should start up, read the Zookeeper, and try to contact all the scraper machines and maintain a connection with them. I would think that is how. So do we need to manually update the Zookeeper config? So what I was thinking, having in mind, is Zookeeper has this concept of ephemeral Z nodes, and whenever it allows us to maintain the health or the group membership management of a set of machines. By that, what I mean is, imagine whenever a machine comes up, it will contact Zookeeper and say, okay, I am available, and Zookeeper will create some kind of an entry for it. On top of it, when a machine goes out of health, then Zookeeper would also know that this is happening, and since it is an ephemeral node, it will delete that node. Now, the reason why that ephemeral is very important here is because deletion of nodes will trigger an update, and that update will go from Zookeeper to the scraper controller. And now the scraper controller knows, aha, some machine is out, and then it will try to redistribute the work. Zookeeper is not a database. Zookeeper, I think you have to read about Chubby or Zookeeper. It is some kind of a place where you can highly available store which stores global data essentially. If a scraper machine goes down, how will it know where to start from? So when a scraper machine goes down, I think it is down, so it won't do anything. So I think your question is, when a new scraper machine comes up, how will it actually know what to scrape? So what I would imagine is that when a new scraper machine comes up, it will trigger a Zookeeper update, and the scraper controller would know that, oh, there is a new machine or a scraper that is ready to work. So what it would do is, I'm assuming, run some kind of a scheduling algorithm inside its memory and assign certain set of machines to the newly created machine. And in order to assign, it will compute the list of mapping from scraper to the list of machines and update it inside Zookeeper. Correct. And once that is there, and it will send control messages to the scraper saying, okay, from now on, scrape these set of machines. Yes. So if the scraper goes down, we would lose 1 second or a few seconds worth of data. In the grand scheme of things, I think it's okay. Who will start the scraper? As owners of the service, we should start the scraper. How does the scraper know? How does the new scraper?
So let's read the
Yes.
entire question for the recording.
Okay.
That we'll hear. So how does the new scraper machine know the already exported metrics by the instance that has been down?
So I did not understand the question, right? I think, at least in my mind, scraper is very, very simple and very, very dumb. Scraper does two things. Number one, waits or listens to the controller's messages about what machines need to be scraped and what machines need not be scraped, essentially. And in my mind, at least, scraper maintains a list of machine addresses that need to be scraped, and it updates the machine addresses based on the control messages coming from the controller. Okay, so that is one part of the scraper. Now the second part of the scraper is actually scraping the machines. So all that it does is, every single second it will just go over the list of machines that it needs to be scraped. It knows it needs to scrape, sends get requests, gets all the requests, all the data back. Now remember, the get requests response would be some kind of a JSON which contains all the data. All that it does is just gets this data, and then it knows how to push this inside a persistent store. Now, does this answer the question? Because I think people are confused about how, let's see.
So let's do something. We're going to move on to the persistent store, how you store and query. And we're going to try and answer those questions in the end.
Correct. I think I don't actually understand the questions, so maybe we can talk about it later.
I think it's mostly a lot of people are not convinced by the pool. I think really that's what it comes to. But
okay.
Let's move on to the persistent store. So what do you use to ingest this much data?
Yes, so the alerting system. So yeah, so I think that brings us to the deep dive for the persistent store. So let us see the characteristics of the writes that are coming in. At least in my mind, these are very high rate of writes, millions per second. I don't see any complex relationships because all we need is some kind of a metric name and a value associated with the metric and its corresponding timestamp. Another important thing here is there is no mutation on the data. When a metric comes in, it's just a metric. We just put it and then move on. So we don't change it later. Another thing would be all the queries happening on top of this data is timestamp based. So this kind of indicates that all the queries should, we typically we don't look at some random stuff. We only look at, let's say, from time A to time B, what was the metric, what was the values for this metric. So that indicates that we need to do some kind of a range query on our database. Given all the above, I would argue that NoSQL database, which is essentially, or which is a wide column store database like Bigtable, would be a good fit. This is because, let's see. This is because it automatically scales to a large amount of data. It usually supports nice append only data. So this is actually quite good, and also it assumes it is well suited for range queries because the range in this case is time. Let's see.
All right. Okay. So what's the partitioning key for this?
Correct.
And
so
also,
now,
please,
yes.
not everyone is really familiar with wide column data store, right? Not necessarily.
Correct.
Right? We may not work with it, so don't hesitate to detail everything that's required to understand that.
Okay. So I will go to the schema of the key. So at least when it comes to wide column or NoSQL databases, imagine just an infinitely long. So someone is asking, is Cassandra a good option? Sure, you can add any wide column data store in this list as well. I would think Bigtable, HBase, and Cassandra are similar. So I think that would be a good thing as well. But based on my research, I saw that Bigtable is used inside Google, and there is HBase used by OpenTSDB. So that is why I mention only these two as of now. Okay. So,
all right, so let's move on to the course.
Wide column store as just a key and a value store that has the ability to keep on expanding infinitely. In that case, the machine or the Bigtable would take care of maintaining all the keys and values for us. So in that case, and it also, the key thing here is it will make sure that it will store all the keys in a sorted manner. Now, the way I would structure the key is that I would put the machine ID, service name, and the metric name in the front of the key, attach it to a timestamp rounded to the nearest hour. If, for example, I have some examples going on, and then I will put all the tags as tag 1 equals value 1, etc., at the end of the key. Bigtables also contain the concept of column families. In my case, and it allows you to add as many columns as you want for a given key. In my case, what I would do is, since the timestamp is rounded to an hour, we can, and each hour has 3600 seconds. So I would have one column each for 1 second. And whenever I scrape a data for a particular timestamp,
do you hear me?
For a particular metric, I'll just put, I know what time I am scraping it for. And if I'm scraping it at 10 PM and 35th second, I'll just go to this row, which is the rounded timestamp of 10 PM, and put the value I see on the 35th column of that.
It's rounded to seconds, the timestamps.
Rounded to the nearest hour. For example, if you have scraped a metric at 10:30 PM, you would round it to 10 PM. Sure. Yes. So 10 PM number of hours. Yes. So number of seconds. But then I think the key point I wanted to make here is that it would round it to the nearest hour.
Wait, but where is the timestamp then?
So this 10 p.m. is the timestamp. So
well, that's a problem. We lose the fact that it happened at 10 p.m. and 5 minutes and 3 seconds. That's important to know.
No, it happened at 10 p.m. and 35 seconds.
Where is this information? Where is the
10 p.m. is here. 35 seconds is here.
Got it. Sorry. Thanks.
Yeah. So maybe I should have made it slightly clear. I should have put something in the minute as well. That way, I could have had a better example.
So tell us, why do you use this key here? Why do you use this type of key? Exactly. Why does it work? Why is it smart to use that?
Correct. I think I have made my imaginary interviewer ask this question as well.
Okay.
Let's see. So I hope this is fine. So this is how the data gets ingested. So every row we'll just put values one column after the other. So coming back to why the timestamp or the key is constructed this way. So let us take a look at the key again. Let me just scroll back. So this is the key. Now the way, so note that all the metrics that are coming in for a particular second, or they are very, very similar in the timestamp, right? So if you put the timestamp at the very beginning of the key, then literally every single service exporting the metric could reach the same backend servers inside the Bigtable or HBase. To understand this, imagine that when I said Bigtable stores an infinite number of keys, but it stores them in a way that it is sorted by key. Now, the way Bigtable works is it segments or partitions the data into small units called tablets, and each tablet is responsible for a range of keys. Now, if you send a query in such a way, so all the same prefixes, all similar prefixes will eventually very likely going to be landed into the same tablet. Now, that is really bad for
what's the difference between tablet and shard?
Let's see. So tablet, yeah, so you can at this, for this discussion, you can imagine that tablet is just a piece of or a range of keys. That's it. So in this case, you can imagine that this infinitely big table is sharded into multiple tablets. In that case, it is the same as shard, for now at least.
What's your prefix here in this key? What is your prefix in this key?
So this is the entire key, right? So the first few parts, any first few parts of this key would be the prefix. I just meant prefix, like the word prefix. So
what do you mean the first few parts? Isn't it defined, specifically defined? What is the prefix here?
So this is the entire key.
Okay, but what's a prefix for a key?
The first few characters of the key would be the prefix, right? That's it.
Okay, few. It's not
any
determined.
Yeah, so any, yeah, so the prefix can be machine ID, can be the prefix. So prefix is just a, prefix is just the first few characters of the key. Just imagine like that, right? So, and also imagine that all the operations on the Bigtable that have to do with the same prefix are very likely going to hit the same tablet or tablet server, which means the machine handling those operations is going to get overwhelmed if all the queries at the same time have the same prefix. Does that make sense?
Okay. So now, please imagine a simple query, a time-based query, time range. I want all the CPU metrics between 10 p.m. and 11 p.m. Let's say it's today.
So you also have to specify the service name, I would think. You cannot get the CPU for all the services, right? You should also specify the service name.
Okay, so in your design, we are not able to just have all the CPU. That's what you said at the beginning.
Correct. So I think that does not make sense to me, but yeah.
Okay, so now tell me, I want all service A CPU between 10 p.m. and midnight, let's say.
Correct.
How do we do that, and how does that work?
Correct. I think the way you should do that is, so I have not spelled it out specifically here, but then you would not want. So at least in my case, you should also specify all the list of specific instances. You should also spell out the instance IDs. You cannot just get all the service names, right? So sorry, you cannot get the CPU for all the metrics. Sorry, you cannot get the CPU for all the machines within the service. You can only get one machine's time series based on the query that I have mentioned here. Now, typical use case in production or industry would be you get all the data, average it out, or get some kind of a median or some kind of a histogram, or in general, it's just an average, and then plot it, right? So in that case, you should probably run some other batch jobs on top of the existing time ranges to compute the averages for us. Does that make sense?
Okay.
What I'm saying
so in
is,
practice, so detail
correct.
exactly the server, like go through the workflow. You see, you had your high-level design on the top. Just imagine someone makes the query. Where is the client here? Where is the client? Okay, you have the client. You said
so the visualizer,
Git,
right? Yeah.
Git is the client.
No. Sorry, don't look at that one. That is rules stuff. So you start from the developers sending off the query to the visualizer.
All right. So guide us through this simple query that the developer does. Which shard is being hit? Which partition? How do we determine the partition? And then are we going to literally get all these rows that you've defined and get all of them? How does that work?
So at least in my mind, my high-level design, it would be easier to understand the high-level design if you already know exact instance, specifically the machine ID that you want to get metrics for.
All right, example, so let's assume that we know it. Let's assume that we know it. Yes.
So machine 0 of service X, and I need to know the CPU for the last 1 hour, right? That is the query.
Okay.
Now, what you do is you just specify the machine number or the machine whatever, the service name, all the parameters to the visualizer. It can hit any visualizer because the visualizer, at least in my mind, could be stateless. It can hit any random visualizer. What the visualizer then does is, of course, check the cache and stuff like that, and then he performs a big table query or big table query. And the big table query, to construct that query, it should be quite simple because you already have the machine ID, you already have the service name. Let's see, where was the key? Sorry, let me try to, yeah. So you already have the machine name provided to you by the developer, service name provided to you, and the metric name provided to you. And to help you narrow down the time range, they have also provided a start time and an end time. So all you have to do is parse or round down the start time to the nearest hour, round down the end time, or round up maybe the end time to the nearest hour, and construct those two keys. That's it. And then you have to issue a request to the big table saying, okay, give me all the rows ranging from this start range to this end range, right? So constructing the start range and the end range keys is very simple because all you have to do is rounding down and rounding up the time range.
Okay, and we are only going to hit like 2 or 3 shards because I asked you just for 3 hours.
Yes. So since it is only a few, we pack all the full hours data into one row. It will just hit, handful of rows.
Okay.
Unless you are doing something crazy.
Problem. Yes. There is a problem in this service. I realized since the past 3 hours, it used a lot of CPU. Did it happen in the past? We are in Christmas. Maybe it happened in the past Christmas of last year. I want to query that. Well, I am able to do that, right? Because all I have to do is use the same range and query just the 3 hours of the last year. But now let's say I want to see, maybe there is a pattern. Maybe it's the end of each month. It's not a really good example, but I would like to actually see from a year ago to now, all the CPU plotted. Am I going to hit, like, imagine the number of shards I'm going to hit with your design. There's going to be a lot of shards I'm going to hit. Are we okay with that?
Yes, so that is a good point. For that, I have covered it in this section. The next deep dive is going to be compactions and downsampling. If we get to that, we can do that. Does that sound fair? All I have. So the simple answer here is I will do some batch jobs which do some kind of compaction or on top of the persistent store, and lay out the data in such a way that you don't bombard the client with too much data, and it does some calculations based on that. We can go into some of the details based on what I am able to think of, but that is the high level idea.
And I would say the main benefit of it is not only that you're not going to bombard the client with a lot of useless data, but also you're not going to bombard your shard.
The server, yes, because
shards,
you are not hitting too many rows. Yes.
Okay. Yeah, that works for me, and I can imagine how this works. Like you are sampling by month, and then let's say the user wants to deep dive into one specific month, he can, but then it limits the amount of shards. So yeah, it looks like it would work.
So we should put some of the intelligence in the visualizer, which is it should first look at the range. If it is more than 1 year or 2 years, it will know that it's going to be too much data. So it should be smart about which type of rows it should query in the big table. If it's 2 years worth of data, it should only query the downsampled rows. If it is very granular data, like few hours, it should query the the real rows, or it could just say this is too far away in the past, we don't have hourly granularity, maybe.
Okay, no, that's fair. Question from someone.
Correct.
From Can. Don't we calculate CPU per region, which have multiple machines? And would that be possible even in the batching solution? Since there is no way to know the corresponding machine IDs.
I think what they are asking is, you have a fleet of machines which have their, so let's say you have a fleet of, let's say 10 machines, or service which has 10 machines, each machine exporting their own CPU, and the machine IDs are in the range 0 to 9. Now you would have, in this case, 10 rows per hour for each machine. So I think they are asking, how do you know the average CPU usage for this service? If you only care about the average CPU usage for the entire service, I think we need to know that quickly. My answer would be to, let's say, do another kind of batch job which computes averages, medians, and rolling windows for different types of services. So that would be the solution, I would think. So if the entire hour gets completed, all we can do is we can get all the hours that were computed, filter out the machines from the same service name, and then compute averages, and then write it back as separate rows. So if a query comes in for service name dot CPU underscore average, you can just quickly get that row directly. I don't know if it made sense, but I think that is the question that is being asked. How do you compute averages and medians? I would just do another. So yeah, how would you know it is from 0 to 9? I think that is a good question. Let's see. Yeah, I don't know. So I think we have to be kind of smart about.
Sorry, I did not follow. I don't. What is 0 and 9?
So I think the question here is, let's say you want to find the average CPU usage for your service. I think that's it. No machine ID, none of that stuff. You know the service name, you know the metric name, and you want to find the average CPU usage for the past 1 hour across all the machines. Right? So how do you do that? I would imagine that batch job. So what I was suggesting was you run through the rows. So over the let's say you run a batch job that does this over the past, let's say 1 hour. Look at all the rows or the machine ID dot service name dot whatever rows, and then group them by service name, compute averages, and then write separate rows for the averaged values of CPU. That would be expensive because, as they pointed out, we need to scan the entire thing, do the grouping by service name, compute the average, and then write it out. I think it should be kind of okay. That is the only thing I can think of. Let me know if I have to explain it correctly or if I am misunderstanding the question.
It kind of makes sense what you say. Let's move on. Did you have anything else to mention?
So for the persistent store, I think the hotspot problem is the only thing I wanted to mention, and I want to make sure that we all understand how the metrics are being stored at the 3600. Let's see.
Yeah, just a quick question.
Yes.
Maybe I missed this part, but how the data will be stored on daily basis? Like 10 p.m. would be repeated every day, right? So do we need to store?
When I say 10 p.m., it's not literally 10 p.m., right? So I think, let me see. It's not literally 10 p.m. 10 p.m. is actually the timestamp.
Yeah, it's the timestamp rounded to the hour.
Oh, okay. Understood.
Yeah.
So it's not literally the same string 10 p.m. Imagine some kind of a timestamp, which would be two verbose there. So I mentioned 10 p.m. over in the example. Yeah, so I think I have given some. So I think I have tried to cover the concept of tags in the thing as well. I would probably skip it. It doesn't. We can go to the compactions because that is, in my opinion, slightly more interesting. So
no, you know what?
So one quick question.
Yeah.
Yes.
So there was a question from a couple of people, like including me, about how do we handle the real-time scenarios or error scenarios, right? So if it is for a pure analytical purpose, the latency is fine. But if you wanted to have some real-time alerting, how do you want to put, how do you see that fit into your design?
So
where you
when
don't,
you say
you can't have a latency, there is no tolerance for the latency.
Yes, so I think I did not go too much. So just so that I understand it, the latency you are talking about is us persisting into the persistent store. That's it, or
persistent store, and from there to the alerting system, right? If you're using one big database and pushing all the data over there, and how you are going to support the real-time alerts. I know it is out of the scope, but your persistent store should be supportive of that too, right?
Yeah, I would add to it, like right from when the log was or metric was generated till it is queryable. So that entire will be the latency.
Correct. That should be kind of quick in my mind, because the scrapes, the scrape jobs just get all the data and then push it as they get it. Now, the reason for designing the number one, the reason for choosing Bigtable is because it can kind of expand infinitely, and it is built for supporting quick append only data. The second thing is, the reason for constructing the key in such a way is such so that we can direct all the writes, which is the ingestion of the data, to as many spread out tablet inside the Bigtables as possible. That way there will be no hotspots and Bigtable will be able to handle the load. Now, that being said, if you want to have even more latency, even more better ingestion rate, you should, I have mentioned that way down as potential improvements. We could have a scheme like this. So do not ingest every time you get some data, but then have some memory in the database, memory in the scrapers themselves, to store the data for the last 4 hours. That way, whenever a query is coming for the last 4 hours, you directly hit the scrapers, get the data from RAM, and then immediately return back. No persistence, none of that stuff. Right? So once the data has passed 4 hours, we can let the scrapers asynchronously push the data to the Bigtable. Of course, in order to not lose the data, we should have some kind of write-ahead log so that we don't lose the data forever. So once that is moved to the Bigtable, then we are kind of safe. But then at this point, we are dealing with data that is more than 4 hours old, so that's not too critical for the alerting anytime. And then more than 6 or 12 months, we can do something that we discussed above, which is do some kind of compaction of the data and then create separate rows for it, maybe in a separate Bigtable or the same Bigtable, doesn't matter. I don't know exactly. Anything more than that, we can put in something that is cheap storage, cold storage, whatever you call it, based on the systems that are available to your company. Okay, I think we should still complete the compactions. I think this is important, interesting at least. So I will maybe slightly touch upon it.
Let's try and be careful about entering in too much detail. I think we understand the idea of your compaction. It's that you use that so that when you use you query a big amount of time of data, it allows you to get it in a reasonable amount of time without querying too many shards.
I think that is one thing. I think the other one is once the entire hour has completed, there is no point in having these entries hanging around in individual columns anymore. What we can do is we can pick up or do a full sweep of this whole row, put all of this data in a single block, and then delete these values. Then any query that is coming in doesn't have to, get all the data. So the key point here is that at least the way Bigtable works, if you put data, multiple entries in the same row across multiple columns, the same key is being stored internally for each of these column entries. That is the key data point. So to save the repetition of the same key being stored for every column that is being stored here, all we can do is just once the hour has passed, the entire data is never going to be mutated again. Delete this and then put this in it's a single block. So you save the key exactly once, you get all the data at once, and you do slightly smaller number of reads. The downsampling for downsampling, I have kind of touched upon two downsampling strategies, but as I think we all agreed during our previous discussion, server-side downsampling is much better. So all that it does is just does some kind of a batch job, runs, looks up data that are more than, let's say, 6 hours old, and then compacts them and then puts them in a single row with lot less data points. That way, when you query, you don't get bombarded with data for all of these points, plus you hit a fewer number of shards. Yeah, so flush outs alerting system, I don't, let's see. Okay, so I think, thank you. Let's see. So yeah, so this is how I would, so if there was any question about ingestion rate and us being able to handle 10+ million writes per second, one way to answer or tackle that question is saying that, okay, you know what, I will not ingest every single second into the Bigtable. I will just put this in memory and append some kind of a file, which is going to be really, really fast, because file appends are very fast. And of course, you need the file appends because you can't afford to lose this data since it is stored in RAM. So append it in or store it in RAM, and whenever a query comes in, we have to make sure that the visualizer server is able to talk to all these different tiers of storages. First tier is the RAM, which will get all the details very quickly, and then Bigtable and so on. I don't have any other. So most of the stuff is based on, some of the stuff at least is based on these two articles. I have put the links here. I have put the links to the document or the article at the very beginning of this chat. Also in the Discord group. I think I don't have anything else to add, and we are kind of out of time. So any questions, comments are welcome.
Actually, we have 10 minutes to wrap up, and then after that, we have 10 minutes of feedback.
Sure.
So great work. Thanks a lot.
Thank you.
And some of the feedback that we had, a really quick one was, let me look at what has been said. Yeah, it was just the machine ID. You can replace them by UUID to allow for because you can imagine that the idea of the machine is not something that every service knows about, right?
Oh, really?
And the machine underscore ID can be different, right?
So sorry, help me understand.
You can have duplicate machine ID across different services. You see,
but that's okay, right? Because we also put the service name, right? So in my mind, at least, that seems okay. So you put the machine ID, even though let's say the same machine ID of 0 is shared across multiple machines, that's fine to me because they would occupy separate rows, because machine ID 0 dot service 1 is different from machine ID 0 dot service 2. So I think that was my reasoning behind this. But yeah, so we can use any arbitrary ID. That's okay with me.
Okay, so the main thing with this design is that you build something that allows for really specific queries.
Correct.
And this is where I'm having issues. Like I would have trouble selling this to an interviewer, and even selling this to build this in a real system. It seems really complex. The pool approach seems really complex. The NoSQL table with big table, it seems complex in the sense that it would be nice if we were allowing more ad hoc queries, like really big queries across all the services, like give me the CPU usage for these services, this entire service, not only specific machines. And
I think at least my thought process over this, purely from interview point of view, my thought process is this. I think as part of the clarifications, it might be good to understand the read patterns and the write patterns, right? So it is good to, I would think that it would be good if you identify some of the read and write patterns and show your intuitions to the insights to the interviewer. If it is overwhelming or confusing, we can directly ask, hey, who are going to be querying and what will the queries look like? I think it is a fair question to ask, and it is okay, in my opinion, to describe a design specifically to what the interviewer asks. The query patterns will be like. So,
all right, so now let's imagine, and I think it's important because I think the question being asked, monitoring a system, collecting metrics, in practice, people can ask actually to build something that allows ad hoc queries, like aggregate by tags, aggregate by timestamp, aggregate by year for each service. How is Facebook performing overall? Not even one service, but all the services inside it. On average at Facebook, we're doing better because we are, let's say, we have a latency, we improved the latency. In 2020, we were at, let's say, 500 milliseconds, and now we are at 300. I don't know. Something really generalist. Now we cannot ask this question with the system we built. And to me, it's a problem for business reasons, right? And it's funny because we never talk about it in a system design, but ad hoc query is really essential, right? Imagine all the time and effort is going to be spent to build this. And then we realize, oh, we cannot ask this, we cannot ask this, we cannot ask this.
Not really, right? So at least to me, right? So I think, so we cannot give real-time and aggregated ad hoc queries all at the same time and persist. So we have to drop some of the constraints in order to get a few other extra things, right? So if you want to store all of this data for, let's say, 2 or 5 years and have real-time query, and be able to zoom in as arbitrarily as you want and zoom out as arbitrarily as you want across machines and services, in my mind, that's not going to happen.
Let's forget the durability. Let's forget querying the last year.
So
I'm just saying,
I would drop the real-time constraint.
Yeah,
because
let's
you
drop
are
it also.
So yeah, in that case, then it's just a map reduce job, right? So all you have to do is just scan the big table exactly once to get what you want in the time range that you want. That's it. So the queries are going to be something around the lines of some business analysts or some executives may be requesting you for a report saying, okay, how did we do resource wise over the past year or the past quarter? So literally once or twice a quarter, 1 or 2 people or maybe handful of people are going to run exactly one job to get this data. That's it. So I think the answer to your question would be batch job.
I see.
That is how I would at least think about it, because you have all the data you need, because you have literally persisted every single second of every single machine in this entire database. Now, if the question is about how you organize this data and present it in a different format, you just query all the data and then just do whatever you want with it. In this case, a map reduce job or it's a batch job. That's it. That's how I would think about this. So the thing you are losing out is the real-time factor, because you cannot do how much is Facebook or Google spending RAM every single second, and I want it right now. That question you will not be able to answer. You can aggregate the data.
So if anyone has other questions, go ahead.
So someone is saying, so same service in different zones can have the same IDs. I would maybe, yeah. So I think they are asking, okay, so the service name in one data center, US, and the service name in another data center can have the same IDs. I would probably say that you can either embed the data center name in the service ID, machine ID, or maybe I should have put service name dot data center also in there. I think that was that is a good thing to add. So that way, we, even if there are running in multiple zones, you can put a zone ID in between the service name and metric name all the time. That way you can disambiguate it. Someone is saying we can aggregate the data and store it in an SQL database to support free form query. I don't know about why SQL database. Okay,
oh,
so
no, so
given
I'm
that,
just SQL database is just so that you can do like a different kind of query, like give me like all the CPU usage for like service A, for example. It just like if you store it in a SQL database, you can do like a more complex query. That's just my and just like adding to your answer, like if you want to support like a complex query, then we can aggregate the data into like a SQL database, and then like SQL database has more like a powerful like a query like a query language.
correct.
Yeah.
My only potential concern there would be, I think, the data size. Bigtable lets you store infinite amount of data, and that takes care of sharding the data within itself.
Yeah,
if you put every single
with SQL database, you have to consider about like sharding the data. Yeah, that has to be manually done. But we're just trying to answer a response about like if we want to perform like a complex query, then
correct.
We can consider like using SQL database. But yeah.
Correct. Yeah. So I think once we figure out how we are going to ingest the entire thing into SQL database, then querying it becomes easier. Or we could say, okay, we'll only compress all this data, process this data, and put a few months worth of data. For example, for this quarter, this was the entire CPU usage. That could be one row in a SQL. So that way you don't have too many rows. Maybe that is another strategy, but yeah.
So the question, so my question would be, will this type of aggregation really help us out? Because say, for example, we are aggregating the data on an hourly basis, like 10 p.m. to 11 p.m. we have aggregated the data and put it in the table, right? And if the query
so
comes
I understand,
up,
right? So just so I understand, what do you mean by aggregate?
Combining the data from like hourly data and calculating an average value or something like that and putting in the table.
Okay.
Yeah. So say we aggregated the data from 10 to 11 and we put in the table. Now, if the query comes, we want the average CPU utilization from 9:45 to 10:45.
So what I would do, right? So I think what I would do is, okay. So yeah. So first of all, I think what I would do is aggregate not across hours, right? I would aggregate across machines. Maybe that is what you meant, right? So for this service, take all the machine IDs. So for this machine, for this service, for this particular time window, which is 1 hour, take all the machine IDs and then compress them into one averaged out value. Is that what you meant?
Yeah, but even if we do that,
correct,
the data which we are querying, it may not fall between that specific time range, right? Because whenever we are trying to query it, it is always based upon the time. So I
one
guess
thing we could do, right? One thing we could do, right, is you are running a batch job to do this anyway. So you can do literally whatever you want. So you can collect. So if you read one row for one machine ID, you will get all the data on a per second basis. Do that for all the machine IDs, right? So if you don't know what machine IDs are there for a given service, read the entire, maybe issue a regex query to the big table, or read the entire rows for the past 1 hour or so, and then group by service name. That way you can in memory get all the machine IDs. You are running a batch job, you can literally do whatever you want, right? So now that you have all the machine IDs, go back, look at all the per second information, compute per second averages. You can do that also, and then store it again in a separate row. I think the point I'm trying to make is, once we mentioned that we are running a batch job on top of the existing data, we completely throw out the idea of real-time stuff. We have to pay the cost of some kind of latency because it is a batch job. So you can do whatever you want. At least that is what I have in mind. I don't know if it would fly too much in the interview though.
Okay.
All right. So if no one else has any more questions, so I see a question here by Can. Can, if you want to ask it.
Oh, what kind of storage would be good after 2 to 3 years so that it is queryable as our needs? Okay, as per our needs, almost like a big table. Yeah, that is actually a good question. I don't know. I would probably, I just put that just to emphasize the idea of a tiered approach. I think your question is inspired by the potential improvement section, where I say over more than 2 years or 12 months, we can move it to cheaper storage if possible. I don't know. So one option is maybe just put it in the big table itself, and just keep it around forever. That would be one option. The other option could be you can put it in some kind of a SS table or sorted string tables in files, and then dump those files into file systems. But the querying would be really, really slow. You can search for sorted string tables that let you store key values in a sorted manner in case you are not aware, and let you relatively efficiently query in the contents inside that file. So you can maybe do something like that. But I did not give too much thought when I wrote that in my potential improvement section.
Okay. So thanks a lot, everyone. Thank you again, XYZ, for this presentation. And hopefully I will see you next week for another presentation.
Sure. Thanks.
Have a good evening. Bye.
Thank you, everyone. Bye.
Thank you all.